Hello and I welcome you all to another super interesting tutorial on data science. Today we'll be working on Numpy. It is heavily used in scientific computing and is a very important package to learn. First we need to install the Numpy package. If you don't have it, you can install it with the help of pip install Numpy. This exclamation mark is needed if you're working or if you're installing it in Anaconda. The objective of using Numpy in Python is to use n-dimensional array. So we will be importing the Numpy package and create an object of it, so we can use the methods inside the package. Now we'll create an array. Say A is an array. So array is already an inbuilt method inside the Numpy package, and we'll just pass a list to make it as an array. So I have passed 5 values inside the list. So if I just print the value of A, I'll get this as an array. Looks very similar to a list, isn't it? So what's the difference, or why we should be using a Numpy array when we already had done so many functions used with a list? Well, the main benefit of Numpy array over a list is, the foremost thing is less memory. The second thing is it's fast. And the third one is it's convenient to use. These are the three things which make a Numpy array. For scientific computing, the usage is much more and better compared to a list. Now let's do a comparison of array with Python list. Say we have a list and we are creating a list of 1000 numbers. So starts from 0 and goes up to 999. Now if I say print, and I'll say here sys dot, if I say get size of, I want to know what is the size of one particular number. How many bytes of memory does it occupy? Say 8. Okay, so sys package is not there, so we'll just install sys. And we'll execute this line again. Okay, now it's telling us that one particular integer takes 28 bytes of memory. So here, whatever integer value you have inside a list, I'll take the length of it, of list 1, and I'll try to multiply it with the number of bytes it's occupying for one particular number. So you can see here it is 28,000 bytes of memory is occupied for 1000 numbers which is stored inside the list. Now let's see what is the memory size, or how do we calculate the memory size of array elements. So I'll use a Numpy array. I want to find it for a Numpy array. So for this, let's declare some array called array1, and if I want a range for an array, I have something called a range. And so now from 0 to 999, the numbers have got allocated to this specific array. Now for printing the size of this particular array, I'll give the array name dot size. So what's the size of the array? It's just like how you calculated the length of a list. So it was like 1, 2, 3, 4, 5. So what is the size of the array? It's 5 elements. But in this case, it is going to be 1000 elements. And we will multiply this array with the item size. That means with the byte size occupied by each number inside the array. Now please remember that in a Numpy array, every integer number takes 4 bytes of memory. So in this case, it should be 4000, right? Because we have 1000 elements. So here we'll just multiply it because we need to see. Here it gave you the size and the item size separately. Let's multiply, so we get 4000 as the size, and here we are getting 28,000 as the size. Now we want to check what makes Numpy array fast and convenient to use in place of a list. So let's declare a variable size which is consisting of say million numbers, and let's create a list of the range of the million numbers, another list with the same size, and let's add the numbers of the two lists. So we'll say result is equal to, and we'll take x plus y for x and y as the iterator, and we'll use zip function here. What does zip do? We have seen zip initially in our list lectures. So if you haven't gone through the list lectures, you please visit it once, because there I have discussed about zip function. So the zip function basically is to map index of multiple containers. In this case, your containers are list, so that I can use them as a single entity. So 0 of list 1 and 0 of list 2, they are mapped together and it's taken as one entity. So then these two values is getting added. So it like this it goes on. Now before I start doing this processing, I need to set the timer. So I'll call it start, and let's set the timer with the time function. And after this processing is done, I want to print how much time it took. So I can have a variable as say final time, which will be the current time right now. I'll subtract it from the start time what we had started, and let's print the final time. So I'll print here the final time. Okay, so we want to get the result in milliseconds. So what I can do is this entire statement, whatever you are getting, the time, I will multiply it with 1000 so that I get the time. So it's 220 milliseconds when you are processing a list. Let's see how much time it takes to process two Numpy arrays. So let's declare two arrays. Say A1 is your first array, and I'll pass the same size, and let A2 be your next array with the same size. Okay, why I had told you that using a Numpy array is convenient, it's because if I want to add the two arrays, it's like I'll say result and add the two arrays in this way. Easy, right? But let's start a timer. So I'll say start is equal to time. Do this processing, and let's calculate again the final time, which is your current time minus the start time when you started the processing. And let's multiply, because again we want in milliseconds, with 1000 and print it. Wow, it's 56.9 milliseconds. So it makes sense to use Numpy when numbers are huge, numbers are humongous. So a Numpy array is much more preferable compared to a list. We just saw the main benefits of Numpy array over Python list. First is the storage, or the less memory what it takes, because in a Numpy array the elements are stored in a contiguous way in the memory, whereas in a list every object is pointed by pointers, and the size of a object in a list is 28 bytes. Second, we saw how fast it is with the help of a timer. And third is convenient, because it's very convenient to do mathematical calculations with the help of Numpy arrays. In the further lectures, we will be going in depth for the mathematical calculations what we can do with Numpy. Thank you so much for joining me in this lecture, and I hope to see you again in the other lectures. Thank you.